Afternoon, everybody. So hopefully we've got a few reminders going off. We had a few more registered, so I'll slowly sort of lead in here just in case people start joining us. But welcome. So this is the Recoup CPD that we've been running monthly. This is wastewater heat recovery for residential new build, aimed primarily for sort of new build developer house technical teams, specifiers, SAP assessors, but it will give sorry, with my screen, there we go. We'll give a brief introduction onto wastewater heat recovery, what it is, how it works, a little look at the various products that we have in a bit more detail, and then a look at why wastewater heat recovery is important for Part L regulation and the direction of travel for sort of regulation on future homes, energy efficiency. And then a kind of walkthrough on designing in wastewater heat recovery for standard sort of house types. And also I have a kind of walkthrough for apartments as well. And then finally, just a case study to finish on. Now this presentation is geared towards residential new build. However, I do have a number of case studies loaded up at the back for non-residential, so student accommodation, hotels, leisure centres and things like that. So if anybody's interested on that side of things, feel free to stay on after the call and we can look at individual case studies there. If not, we should have a non-residential CPD running from next month as well. So that will be available, so just keep an eye on the Eventbrite page. Okay, looks like we've got a few here, so we'll start rolling through then. I would just say my colleague Craig is sat in the background there. He will happily answer any questions that you put into the chat as we're going through. But at the end of each of these chapters, I'll also pause, just check to see if there are any questions from the floor and whether anything needs to be clarified before we moved on. And then just finally, you should have seen here, hopefully you can see my full screen. If not, just to note, there is a fit to frame. So if you click down towards the bottom, I think bottom left of your screen, there's 3 dots there. Press those dots, click fit to frame, and you should get a full screen. So hopefully you can see me. If you can't, that will probably solve it for you. Okay, let's move on then. So who uses wastewater heat recovery? So wastewater heat recovery for showers. It's a energy efficiency technology, essentially a heat exchanger technology that's used primarily by new build house builders and developers in the UK currently, and is being driven by Part L of the building regulations, so energy efficiency regulations. And with the upcoming changes for Part L 2021, it's going to be much more focused now, which is probably why most people are on the call, I would have thought. So our main products are suitable for standard new build housing with showers on first floor and above. However, it's worth saying at this point that we do have products that are suitable for all types of houses, apartments, bungalows, passive house, etc. So we can cover a full suite of residential. But also, as I sort of alluded to, hotels, student accommodation, we have products which are very well suited towards those types of scenarios. And essentially anywhere where there's showers, and especially where there's showers with high shower traffic, so gyms, leisure centres, sports facilities tend to have very fast ROI with wastewater heat recovery, as well as impacting Part L there. And then finally, we're also expecting a big uplift in the interest for retrofitting wastewater heat recovery. In the UK, the main driver for retrofit is funding, and that main funded driver is ECO. We're currently on ECO 4 with, I think, something like £6.4 billion worth of funding available. The way the legislation is set out at the moment is that funding is just available for space heating measures, heating and insulation measures, not currently anything else. But the expectation is the legislation should change soon to allow for non-space heating measures, so essentially hot water reduction and energy efficiency measures. So we kind of see wastewater heat recovery as probably being a real low-hanging fruit when that changes, very similar to kind of the existing loft top-up, but that's something in the future. So who uses wastewater? Why use wastewater heat recovery? Well, It offers significant energy and CO2 reductions for new build or anywhere where it's installed essentially. It's a heat exchanger technology which takes the warm waste or the heat energy from the outgoing shower waste and imparts that into the incoming cold water main. And we'll look at that in a bit more detail in a moment. But essentially it's very easy to incorporate into new builds. It doesn't require a great deal of design knowledge or change to existing house types, which is why it's very much a technology it's been focused on for the transition into new build regulations. It offers simple, cost-effective Part L compliance. That's the real kicker. Whilst nobody really wants their product to be known as a box ticker, it ticks that box for cost-effective SAP points very, very well. It's one of the cheapest and most cost-effective measures available in SAP for relatively high points. But it does have real-world benefits. So installed into a standard new build ensuite shower, for example, our standard pipe can reduce the energy required per shower use by around about 55%. So that's less hot water used per shower, and the hot water that is used is produced more efficiently, and we'll look at that in a moment as well. And then finally, and very importantly, there's no end user interaction required with wastewater heat recovery. It's a passive heat exchanger, essentially part of the plumbing infrastructure. So it can't be switched off, it can't be removed. It always works every time a shower is switched on. And the shower user, so the end user, really won't see any difference in their showering experience. So for most end users in new build homes, they probably don't even know that wastewater heat recovery is installed. So it really is a very good technology in that respect. It's very easy to design in, so we'll look at a sort of designing case studies towards the end, as I mentioned. It is fit and forget, so completely passive, no end user interaction required, as I said, just works with every shower use. And it has a very long working lifespan because it has no mechanical or moving parts, no electrical connections, no filters, no consumables. It really is just, for all intents and purposes, a copper heat exchanger. It has a 40 to 60 year working lifespan attributed by BAEs, so certainly much longer than most other heating and hot water technologies on the market. And it also has a very low embodied carbon. There's a slide to kind of look at that in a bit more detail towards the end, but if you're a specifier looking at embodied carbon, it's really, wastewater heat recovery really is a product that's worth looking at there. So we're going to look at how wastewater heat recovery works generally here with a quick animation. As I said, we have a number of products in the portfolio, but the main one that we focus on, certainly for new build residential, is the vertical pipe system. So that's the product we're going to look at here, and then we'll look at that in a bit more detail, and then some of the other products as well. So excuse me one moment. So just as the animation's loading up here. So it's important to say at the outset that wastewater heat recovery requires a thermostatic shower mixer to be SAP compliant. The reason for that is a thermostatic mixer will allow for a fixed flow rate and a desired temperature regardless of what's going on in the background in terms of hot water and cold water temperatures. So the thermostatic mixer will adjust the ratio of hot to cold in the background to maintain fixed flow and fixed temperature or desired temperature. So normally without wastewater heat recovery, when you're showering, that kind of comfortable 40 degrees or so coming out the shower head is a mix of around about 60% generated hot water, so 60% incoming hot water from about 55, 60 degrees, and about 40% incoming cold water around about 10 or 12 degrees in most cases. And then the mixer will adjust its ratio to give you that sort of 60-40 mix and a comfortable 40 degrees coming out the shower head. Of that 40 degrees coming out the shower head, about 85 to 90% of the heat energy normally goes down the drain and is lost out of the building. So it's a big energy loss, and there's a lot of thermal energy locked up in shower wastewater. And so it's exactly that we use to preheat the incoming cold. So what we do, and as you can see here, we've got a heat recovery pipe. So this is showing the pipe plus HE, but our new product is the pipe hex, but essentially it's a 2 meter vertical pipe which locates on the floor below the shower it's connected to, normally boxed in next to the SVP, and then quite simply that warm waste will flow down one side of the heat exchanger and then vents off to the SVP as normal. So we're not interested in the grey water, we're not harvesting the grey water, we just want the heat energy. And so as the shower's switched on and warm waste goes down the drain, cold water comes in that would normally be feeding the cold side of the shower mixer and replenishing the hot water tank. That is then fed onto the other side of the heat exchanger, goes around the outside of the heat exchanger and is preheated. So in this instance, at standard sort of 9 to 11 litre per minute shower flow rates, we'd expect incoming cold water at about 10 or 12 degrees to be preheated up to about 25 or 28 degrees. So it's a big free issue temperature uplift from that outgoing waste. And that's the basic premise of all wastewater heat recovery. However, there are 3 SAP recognised installation methods which are called System A, System B and System C. And we'll just take a little look at those with these schematics here. So we're looking at the same arrangement here, cold water main going in at the bottom, coming out preheated. And then from there, System A, System B and System C are concerned with where we send that preheated water. So System A is the most efficient method of installation. And quite simply, we send the preheat to the cold side of the shower mixer and back to the hot water source, whatever that may be. So by sending preheated water, so 25, 28 degrees instead of 10 degrees, to the cold side of the mixer, the thermostatic mixer will now adjust the ratio of hot to cold from about 60-40 in favour of more hot to about 60-40 in favour of more cold. So immediately we're using less hot water per shower instance. So less hot water per shower per use. And then also by sending preheated water back to the hot water source. So in this case, we're showing a standard domestic cylinder. Rather than feeding 10-degree cold water into the cylinder that then needs to be heated up to 60 degrees, we're now sending warmed water, so 25, 28 degrees to the cylinder, which then is heated up. So it takes less energy to heat that preheated water than it would do cold water. So we're making energy savings in that we're using less hot water per shower on one side, and the hot water that we are using is being produced more efficiently. So that's System A, that's the most efficient method of piping up. This is the sort of arrangement we would expect on a primary shower in a standard dwelling. So System A is normally for the primary shower, gives maximum impact. Any secondary wastewater heat recovery units will normally be installed as System B. And System B quite simply just sends that preheat to the cold side of the shower. So all we're doing here is using less hot water per shower. What the System B does, it's less pipe work, so it's normally a little bit cheaper to install. It's less efficient because we're only reducing hot water rather than reducing energy on the boiler side. But it does keep the wastewater heat recovery system completely closed loop from the hot water system, which is why System B is normally used whenever there's secondary wastewater heat recovery units. So System A or C on the primary, because that integrates with the hot water source, System B on anything secondary. So if you've got 2 showers in a home, for instance, one would normally be System A, one would normally be System B. That covers all of the showers with wastewater heat recovery. And then just for completeness, System C, as you've probably guessed, is where we send the preheat just to the hot water source only. Now this isn't used too often, but where it is beneficial normally is if you've got a townhouse arrangement. So if you can imagine you've got a 2nd floor shower stacked above a 1st floor shower, you can normally feed the waste from both showers into the wastewater heat recovery unit located on the ground floor, and then just to reduce the amount of pipe work, cold feed, preheat, and then that just feeds maybe the cylinder in a utility room on the ground floor or something. So System C sits in between in terms of efficiency and is a way of designing in a little bit more cost efficiently, maybe using a little bit less pipe work. So System C is normally used on townhouses in residential. So just to qualify the savings in a bit more detail, standard sort of UK shower flow rates around about 11 to 9 litres per minute. It's worth mentioning that under new SAP, specifiers can specify flow rate for showers, and certainly wastewater heat recovery works in the same way as most heat exchangers does, in that if you slow the flow rate down, you tend to get a better efficiency. So sort of down at 5 litres per minute, for example, the efficiency will be much more. But these are pretty much sort of considered standard flow rates, shower flow rates in the UK. So at 11 litres per minute, on System A, the heat recovery efficiency is 63.6%. The energy demand reduction in terms of hot water reduction and less energy at the boiler side around about 54% reduction in the amount of energy required per shower, and at 9 litres per minute, that's around about 58%. It's probably worth mentioning here as well, all of the efficiencies that we tend to quote are third-party tested and validated by Kiwa, which are an international test house set up to test wastewater heat recovery. They're based in Holland. And then that data is taken by BRE and used to plug into the UK SAP database for building regulations. So we tend to use SAP determined efficiencies when we talk about case study information and things. So just to let you know there that everything is third-party tested and validated. And then for system B, 11 litres per minute, that energy demand reduction, or in fact in this case it's a hot water reduction, is around about 40%, and then at 9 litres per minute around about 43%. So less efficient, but still significant in terms of the amount of hot water reduced per shower. So yeah, so both installation methods are very significant, certainly for new build homes. I'll just pause there just to see if there's any initial questions, Craig.
Nothing in the chat.
Okay, sounds like I'm doing a good job. So we'll move on to just some more detail on the product types then. So as I mentioned, the main product, or certainly the most specified product for new build housing, is the vertical pipe system. It's a 2 metre or 2.1 metre heat recovery pipe, which will normally box in next to the SVP. Invariably, the SVP is sort of within a few metres of the shower above. So it neatly boxes in next to the SVP, doesn't really take up a great deal of detail. So what we're seeing here is the shower above, warm waste on the yellow here coming into the turbo rotator and dropping through the pipe and then venting off to the SVP as normal. This particular example is taking waste from the shower over bath. I'll look at that in the case study at the end. So the way it works and how we get our high efficiencies, our pipe hex is one of the highest efficiency products in the SAP database. What happens is that warm waste comes in, goes into what we call a turbo rotator. This is simply used to direct the flow of water so it spins cyclonically, and then that promotes what's called thin film heat exchange. So it promotes that warm waste to cling to the inside of the copper heat exchanger pipe, and so we get what's called falling film or thin film heat exchange. Essentially, warm waste clinging to the inside of the pipe, so we're maximising the surface contact. That heat energy from the warm waste then imparts to the copper heat exchanger, and then cold water main comes around the outside. So we just sort of highlight that here, pretty much as we showed earlier. Cold water main coming in, goes around the outside of the exchanger pipe, comes out preheated. In addition to what we supply as a product, so the heat exchanger and the installation pack, all that's required from an installer is usually just a double check valve on the incoming cold water main, 2 isolator valves, and then 1/2-inch BSP irons for connection. So that can connect to 15mm pipe, 22mm pipe in most cases, but that will be specified. But yeah, so it really doesn't take a great deal of extra plumber's time, plumber materials to install wastewater heat recovery. Usually installed at first fix, normally 1 to 2 hours of extra plumber's time. Just if anybody is looking at this from a non-residential point of view, this slide just shows how wastewater heat recovery can be used for instance, student accommodation or hotels, often with back-to-back showers in rooms. What you would look to do for cost efficiency is drop the waste from both showers into a pipe in a service riser and then connect that as system B. So we're just feeding the preheat to the cold side of each shower mixer, and that can just be replicated floor over floor over floor. Very cost efficient way of installing wastewater heat recovery with very high efficiencies. As I said though, in standard residential setups, wastewater heat recovery really takes very little changes to existing designs. So if you've got house types which are on old regs, looking to migrate them onto new regulations, the addition of wastewater heat recovery realistically just adds about 200mm to the SVP boxing. So normally your SVP boxing is about 220 by 220mm. Adding wastewater heat recovery, about another 200mm in one direction. So really is very, takes up very little space in the home. And then unique to all of our products, we use a double-walled heat exchanger construction. So this is just a cut through of the heat exchanger pipe, but it's the same for all of our products at the moment. We use a double-walled exchanger. What this means is that, just a note on the construction. So you can see we've got smooth internal copper surface for the warm wastewater to cling to. The eagle-eyed amongst you will see that there are striations running down the middle of the copper exchanger. We use a mechanically pulled pipe through pipe construction. So these striations run the entire length of the pipe, open top and bottom. And what that does, it gives us a visible leak detection system built into every wastewater heat recovery unit. What it means is that if there was ever a breach or a perforation within the exchanger, the outgoing grey waste couldn't mix with the incoming cold water without giving a leak at the bottom. So that leak detection system means that we can directly comply with EN 1717. And what it means in practice when you're designing wastewater heat recovery or using wastewater heat recovery is that the shower trap stays under the shower where it belongs rather than having to be located under the wastewater heat recovery unit. There are some products on the market which use a single walled exchanger. That tends to give a little bit more efficiency, but the problem is that you need to have the shower trap underneath the wastewater heat recovery unit. That potentially leads to problems in terms of extra installation height, the fact that you've got a bath trap or a shower trap underneath the unit on the ground floor means it needs some kind of inspection, and also it potentially adds for falling water noise and the potential for blocking on the ground floor. So we've avoided that in our design, and everything is double walled, so we directly comply to EN 1717 and UK water regs. It's also, it's a belts and braces approach to compliance, because every single product individually is pressure tested before it leaves the factory. So we're 100% assured that there's no issues with the exchanger, but it is a belts and braces approach to compliance. And it means, as I said, the shower trap stays in place where it belongs. In terms of price, the units are priced and very competitively for developers, stocked and sold through all of the main UK merchants, but certainly we are the only product that's stocked and sold as standard through City Plumbing, PTS and Wolseley, so available through something like 2,000 branches nationwide on next day, and certainly a very cost-effective product. Certainly would expect for most developers sub 450, 500 pounds installed, so it really is a very cost-effective product for the amount of SAT points it will gain. And I've kind of covered this already, but in terms of installation operation, quick to install at first fix, only basic materials, tools and knowledge required, so your existing installer network will be able to install this and understand this very quickly. No specialist training, no commissioning, no MCS accreditation, certainly no planned maintenance going forward, so the wastewater heat recovery units can be boxed in as long as there's reasonable access, and no behavioural changes, so you shouldn't expect any calls back once wastewater heat recovery is in. Very long working lifetime and part of the plumbing infrastructure. I'll just pause there just one moment. Any questions on the pipe before I move on, Craig?
There's one question from Caroline regarding suitability for retrofit and the heat sources that it can be used with, so possibly gas boilers or electric water cylinders.
Great. So yeah, sorry, I didn't mention about heat sources. So wastewater heat recovery as a technology is heat source agnostic, so gas, electric, renewables, it really doesn't matter to us as long as the hot water generator can accept a preheated incoming cold water main, and in reality most things can. Combi boilers, for example, can, cylinders can, most renewables can. So yeah, it normally doesn't really matter from our point of view what fuel source is creating or what plant type is creating the hot water, as long as it can accept an incoming preheat. If it can't, then you've always got system B as an option anyway, where you're just connecting to the cold side of the shower mixer. So that hopefully covers that. In terms of retrofit, we'll come on to that with these next products actually. The pipe system certainly can be retrofitted, but obviously being installed on the floor below the shower it's connecting to, it depends at the level of retrofit you're going into. So if it's a homeowner looking to install it for their own bathroom, probably not the best option because you have to go down into the plasterboard down below. But if it's a hotel refurb or something along those lines, it may well be an option. Void repairs in social housing, for example, it could well be an option. But that really kind of leads quite nicely into the next product. So the vertical pipe product is fantastic in that it's very cost effective, it's high efficiency, but the negative is that it's gravity fed, and so it needs to locate on the floor below the shower it connects to. So great for first floor showers and above, not so good for bungalows, for ground floor showers, and potentially for retrofit. So we have other products in the range. The Easy Fit is probably the next most cost effective option. This is a standalone horizontal wastewater heat recovery unit that's designed to locate in that void space either underneath the bath or underneath a shower riser tray. By design, not quite as efficient as the vertical pipe system, which is why we normally try and specify the pipe where possible, but costs relatively similarly, and certainly in apartments it can score similarly in SAP as well, just due to the way that SAP calculates hot water use in apartments versus houses. So certainly a good primary option for apartments with, for instance, thermostatic mixer showers over baths as their primary shower. So that's a good option there. As you can see here, if you have a riser tray, certainly a suitably sized riser tray, the Easy Fit can potentially locate underneath there as well. Normally anything from about 1400 millimeters onwards. So they are quite big trays, but it's a horses for courses thing in this case. But we have other options as well. The Easy Fit works in the same basic way as the pipe system does. Warm waste goes in one side. In this case, it floods out across the base of the tray, and then that will vent off to the SVP as per normal. So again, we're only interested in the energy, not the grey water. Cold water main comes in the opposite side, so for counterflow heat exchange. In this case, we've got a kind of a flat serpentine heat exchanger, so lots of surface, rolls all the way through in the serpentine way, comes out preheated. Again, double check valve, 2 isolator valve, that's all that's required for installation. And what happens here is the heat exchanger is designed to be around about 2 millimeters above the base of the wastewater heat recovery pan. So as that warm waste goes into the unit and floods out, at the sort of standard shower flow rates, there's enough waste flow there that it will roll over, turbulate and mix over the exchanger, giving lots of mixing and lots of surface contact and lots of heat exchange. So this product scores very well in terms of efficiency, and certainly I think the next closest product on the in production on the SAP database, it's around about 40% more efficient than that. So it really is sort of sitting out there at the moment in terms of efficiency, but designed essentially so that with that 2 millimeters, so that at the end of the showering, when the flow rate drops down, any debris, any hair that might have got through the bath trap or the shower trap, which again remains in place under the bath, would just flow through the unit. So it's designed from the ground up, completely different to anything else out there, and designed essentially so it won't block. So we're not sort of funneling the waste through small gaps or anything like that. It's designed to allow it to flow through the unit. And these have been in the market for sort of 5 or 6 years now, and certainly no issues in that respect. So it's certainly doing what it's supposed to do. Just to kind of give a quick look in terms of how much room it takes. So this is a standard side bath from our installation diagrams. Depending on where your SVP might be located, if it's located towards the shower side of the bath, then that's fine, we've got covered there. If it's located on the opposite side, then the same unit can be installed slightly differently. So with flow running through, waste coming in that way, dropping down and out, or the waste pipe will drop over the top of the unit and then run down and through. In terms of, we normally get the question of how much room does it need. Around about 105, 110 millimeter clearance is normally enough for the unit and for a bit of lift on one side to give full. So yeah, generally 105 millimeters or thereabouts. So again, it will also sit underneath a standard riser tray. So, sorry, it's a bit of a bigger slide than that should be that one. Okay, so that's the Easy Fit. So the Easy Fit, as I said, will under baths, that showers over baths is absolutely, that's normally the best option, and certainly shower riser trays. However, there's also been a trend recently, certainly in apartments, for low-rise shower trays. So we wouldn't normally recommend that the EasyFit, being a heat recovery device, is sort of dropped into the floor void or installed underneath a fixed shower tray. So we've developed a pumped option to team up with our pipe. So what this does, it leverages the high efficiency of the pipe system, but allows it to install on the same floor as the shower it's connected to. So in this case here, we're looking at the a low-rise shower tray. The waste from here will flow into the pump. The pump will then activate. This is an off-the-shelf Saniflow flat pump. We've teamed up with Saniflow because they've got great pedigree, great warranty, great servicing, and have been in the market for a long time doing what they do best. That will then activate, and that high velocity pump the warm wastewater up into our turbo buffer. So this is a turbo rotator inside with a buffer tank. And then that will just drop that warm waste through the pipe as per normal. So it's almost as if it's being gravity fed from this part and then off through. So we're leveraging the high efficiency of the pipe, but allowing that to be installed on the same floor as the shower it's connected to. So again, ideal for apartments where maybe you've got additional en-suites, for DDA enabled bathrooms or ground floor showers. And again, if you're looking at a bathroom retrofit as a homeowner or a social housing, this could be the option as well here. So either the EasyFit for an underbath retrofit or the Pipe Hex Active as a same floor solution for retrofit as well. As I said, depends on the level of retrofit you're going to, but this certainly has the potential there. So designed to give sort of flexibility in how it installs. So there's a couple of CADs here which I can send to anyone that's interested, but essentially, let me drop through to the next one here. So we can, around about 2 meters is allowable between the shower trap and the pump, and then around about 1 meter or so between the pump and the pipe. So for designing to most bathrooms or modular pods, that sort of thing, we can be very flexible with this, and Recoup can support you in terms of designing in and things. As I said, same SAP listed efficiency as the existing pipe, so it really is a very high efficiency system in terms of a same floor solution, and certainly we're seeing a lot of interest for both residential and non-residential for this, apartments and things. Just to complete the picture, not really used too often in residential, but we do have a range of wastewater heat recovery integrated wet room drain channels. So these are linear wet room drain channels that would normally be recessed into a tiled wet room floor or a vinyl wet room floor. Anywhere between sort of 35 and 57% efficiency, depending on the product. But these work in a similar way. However, all of the heat recovery elements are built within the body of the unit. So everything is completely accessible. So we're showing the Drain Plus unit here, the Drain Plus Duo here. And this works in a similar way again. Warm waste will flow along the wet room floor into the drain channel, onto the percolation plate here in this case. These holes you will see here are kind of strategically placed that they would line up above the exchanger, and then that will fall, thin film, heat exchange, and then the trap and the waste then runs off to the main drainage as normal. So all of the wastewater heat recovery element is located within the drain here. These are very robust units, absolutely fantastic for commercial showering environments, for gyms, for high shower traffic use. And the ROI is pretty incredible, anywhere between sort of 1 and 3 years, depending on the amount of shower traffic. But I've got some case studies loaded up in the background if anyone's interested in this type of product. That's as far as we'll go on products, then we'll just sort of have a little look at Part L compliance and things now. Any questions, Craig?
One around hard water and scaling.
Yeah, generally not an issue. So because we're only preheating that cold water up to sort of 25, 28 degrees, we're not getting much hotter than that on the cold side. So generally scaling isn't an issue. Realistically, those sort of temperatures aren't much more than the sort of allowable cold water mains temperature in summer, etc., allowed by most water companies. So it isn't really an issue for scaling. Certainly probably out of scope from this presentation, but we do have some monitored installations sort of running over 8 or 10 years looking at sort of efficiency drop off over time, and realistically there isn't any. So we kind of look at those in terms of scale build up and things. So I can talk about that separately if anyone's got any wants more detail on it, but essentially for residential it isn't a problem. Certainly we've been in the market here in the UK for sort of 11-12 years, not seen any issues there. Our products are designed and produced in Holland, which is a centre of excellence for wastewater heat recovery. It's been designed into new build for sort of 23-24 years there, and again no real issues with scaling that sort of any significance, so shouldn't be an issue. Okay, so why is all this important? Why are we looking at hot water? Well, traditionally and sort of historically in houses, heating, space heating demand has always been around about 2/3 of the energy, with hot water being much less, sort of 15, 18, 23%, depending on sort of usage patterns and things. So hot water has always been the lesser part of the energy budget in the home, and quite rightly, you know, historically regulation has focused on insulation, on space heating efficiency, and has done a very good job of that, and the regulations have driven more insulation, more air tightness, and so space heating demand has come down as we've gone forward. So, but of that hot water demand in homes, and certainly in houses, showering takes up around about 50%, and certainly more in some cases, and in apartments it can be anywhere up to sort of 80% of the generated hot water in a dwelling. So showering really is a big energy user, and certainly the biggest part of that hot water production in most dwellings. So it really is something that needs considering. And as I said earlier, about 85-90% of the heat energy from the shower head's going down the drain. So it really is a big heat loss, and essentially a very big thermal bridge within a home. So it's something that needs addressing. So if we look at that kind of sort of historic average house, with 2/3 of the energy being used on space heating, around sort of 23% on hot water generation. If 50% of that hot water use is for showering, and we're throwing 85% down the drain, that's potentially around about 10% of a home's energy budget that can be lost down the drain. So it really is quite important. And then as we look towards newer regulation, where space heating demand is being lesser because of air tightness and insulation, so this is looking at a sort of a standard 3-bedroom home on 2020 regs, space heating is lesser, but even though showering habits aren't expected to be any different, so this is on a kind of same basis, hot water demand would be by comparison more, or a bigger percentage of that home energy budget, and therefore showering would be a bigger proportion of that home energy budget, and therefore the amount of energy going down the drain is a bigger proportion of that energy budget. So looking forwards, wastewater heat recovery really is an important technology to reduce energy use in home further. So it's been done very well by space heating, but now hot water really is the next sort of challenge for new build in most cases, and that's certainly being borne out by the regulations. So I won't go into too much detail here, and I know we're kind of running quite a bit low on time as well, so I'm going to rush through the last few bits. But the Future Home Standard, which is due to come into force sort of 2025, 2026, essentially is looking at the ban, or the no more use of fossil fuels for heating homes, and moving to all electric. The idea of moving to all electric is that as the electricity grid becomes 100% renewable over time, that any new build home built from 2020 in England and ultimately the UK will decarbonise as the grid decarbonises. So by not using fossil fuels and just electric, as the grid becomes greener, the whole UK new build homes become greener as well, become zero carbon, and ultimately don't need retrofitting to do that. It's just about the grid decarbonising. However, in the interim, I'll move through this pretty quickly. In the interim, we have Part L 2021, which is the current building regulation, which is currently in a transition period of 1 year. That 1 year transition period for England finishes in June 2022, so 2 months away. From June 2022, all new build homes in England will need to be built to the new regulations, and essentially they're looking at a 31% CO2 reduction over previous regulations. So it's a much tighter energy efficiency demand on new homes going forwards. And the notional dwelling for the first time has included wastewater heat recovery as standard. So the notional dwelling is BRE's most cost-effective recipe for Part L compliance, and certainly this being wastewater heat recovery being included in this is really what's driving a lot of interest for wastewater heat recovery. So the expectation is that gas boilers will still be used in the main, low temperature heating, so 55 degrees flow is specified. PV is expected to be standard, with wastewater heat recovery as standard, and then higher efficiency in terms of air tightness and insulation across the board. So that's kind of the expected standard recipe for Part L going forwards, and that's where we're transitioning to in a couple of months. So yeah, it's driving a lot of interest in wastewater heat recovery, of course. So now the regulations, current regulations do allow for air source heat pumps. Obviously air source heat pumps are getting a lot of press at the moment for some good, some bad reasons. Air source is a fantastic technology, and certainly under the current regulations, if you were to pretty much just bolt on an air source heat pump to an existing home with slightly increased fabric to meet the fees, you're going to get a SAP pass. However, the issue currently in the UK with heat pumps is that there isn't quite the infrastructure and the installation supply chain to allow for heat pumps to be used across the board on all new builds. So the expectation is that heat pumps will build and build relatively quickly in a short amount of time. But as it is at the moment, gas boilers are expected, certainly for the main developers, for the sort of the volume developers, to be still probably about 85–90% on their new build homes going forward. So that's kind of what we're seeing, and certainly the feedback we're getting from the developers that we speak to. Recoup tend to sort of target the top sort of 10, top 20 developers, and certainly gas boiler, wastewater heat recovery and PV is really the mix that's looking most popular going forwards. I'll kind of leave that there, only just to say it's not just us that's saying this, it's not just BRE, there's a lot of independent work being done on how to achieve net zero with new homes, how to achieve much higher carbon reduction with new homes. And if you haven't seen it, the Future Homes Hub has done some fantastic work on helping developers transition from existing regs and existing sort of footprints and fabric measures into new build homes. But certainly across the board, and even with air source and direct electric, they're suggesting that wastewater heat recovery should be used. Not necessarily for the SAP points with air source, but because of the secondary benefits of by reducing, significantly reducing the amount of hot water demand, it tends to even out the seasonal spikes in hot water demand that tend to test air source heat pumps often. So it allows for sort of smaller cylinders to be specified, reduces short cycling, lots of other secondary benefits. So it really is worth looking at if you're considering air source and other electrics, heating and hot water solutions as well. I'll kind of just skim through this. I'll send this out to everybody at the end. So if you want to look at that in more detail, you can do. Any questions before I move on to the design element, Craig?
Yeah, 2 or 3 questions. Maintenance on the drain systems, what's required?
On the recess drains, essentially the wastewater heat recovery element is planned maintenance free, as all wastewater heat recovery is. However, if you are installing into high shower traffic environments and commercial environments, any wet room drain is going to need an element of planned cleaning within that. So that's why the whole unit is designed that the cover plate can come off, the percolation plate can come off, and everything is accessible. So periodically, you know, maybe weekly, maybe monthly, maybe quarterly, the unit will need to be pulled apart and cleaned inside and just check that it's free of everything. But that will simply depend on, you know, it will be part of the standard cleaning regime based on the amount of shower traffic there, not really impacted because it's wastewater heat recovery. You would just expect that with linear wet room drains regardless, because obviously they're collecting hair and things that goes through football boots being banged out into them, that sort of thing. But yeah, they certainly are a very robust design, and we've got those installed into gyms and other areas like that for sort of 5, 6, 7 years now. So we've got some good case studies there if anyone's really interested. Okay, just to kind of Sorry.
Sorry, Alice. There's a couple of questions. Sorry. One was around the legalities for apartment blocks where you have the pipe located on the floor below and the sort of
Yeah, good
ownership
question.
structures.
So that realistically, the pipes in apartments is probably not an option. Build to rent, possibly in service risers. We've seen some specifiers looking at the pipes for build to rent models because obviously the whole building stays in single ownership like it would with a hotel or student accommodation. But for apartments that are designed for retail sale, I wouldn't normally suggest that the pipe would be an option there. That's where the Easy Fit comes in. That's where the Pipe Hex Active comes in. So there's other options there for apartments. And again, we can, and hopefully you'll, by the end of this, we can support you in designing in and recommending the right products for various scenarios, which is what this section's about to be.
One more question, Alice, was just on a sort of a rough ballpark installed cost for a retrofit in terms of an Easy Fit under bath.
How long's a piece of string? I mean, if it's simply going a unit going under a bath where you can take the cover off the bath and installing a system B, so taking the cold feed that's currently feeding the thermostatic shower, relocating it through the unit and then back up again, realistically 2-3 hours of plumber's time, I would have thought. It really shouldn't be a great deal more. It's standard plumber rate, I would have thought. So, and the units themselves are similarly priced to the pipes. So, I think Jewson online are around about £450 or something like that for the Easy Fit. Might be a touch more. So that plus a couple of hours of plumber's time, I would have thought. Okay, right. Okay, just moving on then. So, in the main, for most standard house types, wastewater heat recovery is normally going to be pretty easy to design in. Usually the best option is the pipe system installed as System A to the master ensuite, and ideally, if possible, covering other showers if they're close by, or covering all showers with 1 or 2 wastewater heat recovery units. So certainly apartments, 2 and 3 bedroom homes, a single wastewater heat recovery unit will normally give the biggest impact, especially when installed as System A. If you've got bigger house types with 2 shower rooms separately, then as I said earlier, 1 pipe installed as System A, second one as System B, that would normally give complete coverage and be relatively cost effective and have a big impact in SAP. But certainly if you can look at designing in bathrooms sort of reasonably close together within a few meters of one another, back-to-back showers, en suites and bathrooms, for example, they can normally benefit from both waste going into a single pipe, or as I said earlier, with stacked showers on townhouses. So often, 2 showers might be able to install to a single vertical pipe, and that then maximises the cost efficiency, keeps the cost down, keeps the SAP points high. Again, we can discuss all of this with you on a kind of plot by plot or development basis. So do feel free to get in touch. Certainly Craig and James also sat in the background there. A lot of what we do is going through house builder plans and making recommendations and then sending that off so that you can informatively SAP model to find out what the best options are for you. But just to kind of bring all this together in a bit of a sort of walk through and look at the impact in SAP. This is just a standard sort of 3-bedroom home, 2 bathrooms, a ensuite shower, thermostatic mixer, and then a standard bathroom with just a handheld shower, so no thermostatic mixer on this. The shower doesn't count as a shower in SAP. So if we look at this, the option here, as I said, is going to be a vertical pipe installed System A to the master ensuite. That gives essentially full coverage on the from wastewater heat recovery point of view. If you send drawings to us, we'll normally come back with a kind of tabulated list of options. In this case, not too many options, but for bigger homes there can be. But whenever we do this, we'll always send back specification notes, design and installation notes, so that as this follows down the supply chain, your installers will know what's been installed and why. And then for the SAP assessors, we always put the PCDB number in as well. So rather than having to go through pages and pages of different options, you can just pop the number in and it will populate the correct product and the correct installation method. So we kind of send all this back just to really streamline the modelling process for developers and SAP assessors. Just on that, I'm not sure if there are any SAP assessors in the room, but SAP 10.2, which is an online system, is working very, very well at the moment. It's relatively easy to model wastewater heat recovery. Go to the hot water element. As you can see here, check the box for an instantaneous wastewater heat recovery. Pop in the either the PCB number or the details, so a pipe hex installed as system A, for example. Pop in the number of baths, so in this case it would be 1. And then the important part is you need to click this little plus sign to connect your wastewater heat recovery unit to the shower it's going to be connected to. So this is a difference in SAP that wasn't there previously. Once you press the plus button, you can then enter the shower name, so ensuite shower, specify a flow rate, anywhere between, I think, 5 and 13 litres per minute. So obviously lower specified flow rates will use less water, less energy, improve the SAP score. So it's certainly worth considering that if you're able to specify shower flow rates, and then connect that, in this case, to instantaneous wastewater heat recovery number 1. Press the button and then that will output the SAP score. So just looking at a kind of an overview on SAP score then, and the impact of wastewater heat recovery. If we look at that 3-bedroom that we were just looking at there, mid-terrace or detached, with a system A to the ensuite, pipe hex systemated ensuite, would it expect, or a calculated primary energy reduction, so a reduction in the overall energy from the site of 10.7%. So really is quite significant, and if you remember back to the pie charts, kind of ties in to similar sort of numbers that we were seeing there as well on the theoretical side. And then in terms of sort of a CO2 reduction or a SAP score, if you will, around about 11%. So really is quite impactful from a single unit, and certainly there aren't many measures at this kind of installed cost that's going to give that kind of output. So the options for maybe reducing the amount of solar PV on the roof, or reducing other more costly measures or troublesome measures when wastewater heat recovery is used. And then I'll leave this with you, but certainly have an impact for sort of bigger 4 or 5 bedroom homes and things like that as well. So yeah, so that's kind of the SAP score. Certainly from a developer point of view, you're looking at the most SAP points for lowest installed cost is normally where you would kind of see the ROI on this. But obviously ROI can figure for social housing, for different types of hotels or student accommodation projects and things like that. So we can look at this very, very granularly, and we can produce bespoke calculators, not really used for new build developers, but certainly for other projects or social housing and things if you're looking at large scale upgrades and things. So more than happy to put sort of bespoke calculations together, but this one is just based on that 3-bedroom home with all the SAP defaults inputted, and we can see here there's a sort of an energy reduction of 1.7 kilowatts per day based on 2.3 users on average, and 0.73 showers per day. So these are the SAP defaults that's used in the modelling. And then this can give us sort of ROI figures based on different fuel types. I think this is using current price per kilowatt. And then we can also work out CO2 reduction things. One thing I'll just say, just to take note of at the moment, so this is the annual CO2 savings per year on that 3-bed home on gas, and then if we kind of consider on an air source heat pump there, and then just to use that to frame against the embodied carbon score. So we were lucky enough to work with Support SIBSI on their TM65 standard for embodied carbon, so we got quite early visibility on the embodied carbon calculation for our vertical pipe system, and that came out at 53.63 kilograms per product. I won't go into all the details now, but I'm happy to talk embodied carbon to people afterwards if they're interested. I'm just a bit conscious of the time. But just to kind of frame that, if we go back to those annual CO2 savings just on a single pipe in a 3-bed home against gas, 164 kilograms, against air source heat pump, 131 kilograms, really is a very, very low amount of carbon required to produce the product when you consider the amount of operational carbon it can save per year. So yeah, if embodied carbon or life cycle analysis is your thing, wastewater heat recovery really is quite exceptional in terms of the amount of CO2 required to produce product, mainly because it's very highly recyclable. We use a circular manufacturing process where we can remanufacture old products and things like that. So, but we can look in a lot more detail if anyone's interested. Just a very quick walkthrough on designing into apartments, because it sounds like there's somebody in the background with eye on apartments. Again, very similar, but realistically, as we said, the pipe isn't going to be an option in most cases for apartments. So realistically, you're probably looking at the easy fit. So if you've got a primary bathroom with a bath and a thermostatic mixer shower over, as most apartments tend to have, then the easy fit is probably going to be your biggest bang for your buck in terms of sat points in an apartment. So that's probably the first one to look at. Again, goes under the bath as we showed earlier. You can also look at the Pipex Active if you've got showers, so ensuite showers as a secondary. So that would then give more coverage with wastewater heat recovery, potentially increase the SAP score a little bit more. And also there is an option to, if you've got sufficiently large showers, that the easy fit can drop underneath a riser tray, for example. So there are different options there. Kind of all of these options, unfortunately, for apartments have an element of compromise, because, you know, ideally we'd want to use the pipe, which is the most efficient, but we can't. So then you look at the other options. So, but we're more than happy to sort of discuss that with you. Sorry, these seem a little bit out of sync. I'll hold that there. And just very briefly then, just going, we're running towards the hour. We've been in the market now in the UK for 10 plus years, sole supplier to Barrett, supplier to Redrow. So we've got tens of thousands of these units installed in new build houses. But looking to the future, this is a great case study from Barrett, where they've developed their Z House concept, which essentially is looking at how can they use existing house types and floor plans. So this is one of their existing 3-bed homes with technologies and sustainability and biodiversity technologies that are already in the market to produce a net zero ready home now. So around about 40 or so different technologies have been trialled in this home, and they're also working on the Energy House 2 as well now. So a really good project, but essentially uses wastewater heat recovery for that primary hot water demand reduction. In this case, as I sort of showed at the earlier slide, we're connected to both the ensuite shower and the shower over bath, which sits off around about here. This is the Z House concept with a wastewater heat recovery unit in. Interestingly, with this project, it is an air source heat pump, very low flow showers, so the Kelder powered 5.5 litre per minute shower on the ensuite, and a standard flow restricted shower over the bath, and the wastewater heat recovery is working perfectly well. So a nice way to kind of end on a case study there, just looking towards the future and net zero, and showing that wastewater heat recovery really is a future-proofing technology for new homes going forwards. Thanks very much for your attention, everybody. I will make the slides available to you. Just to say, we do also operate a CPDs for Trees program, where anybody that generates a CPD certificate off the link that we'll send you, we donate 25 trees, just part of our sustainability drive. So yeah, please do respond to the CPD certificate, and then we can generate those trees. And I will pause there, just see if there's any final questions, and if anybody does want to stay on and look at other case studies or anything else to discuss, I'm more than happy to stay on.
There's nothing in the chat at the moment.
Okay, good. Any questions from anybody? Yeah, absolutely. I'll share the slides. Yep.
Yeah.
I think we've recorded this as well, so this will be up on our YouTube channel shortly, as are some of the other monthly presentations as well. I'll send all those links across. Brilliant, thank you very much. Okay then, if that's it, then I will sign off. The chat will remain open as well, so if you've got other questions, pop them into the chat. You know, floor plans, anything along those lines, but I'll follow up with it really very shortly. So thanks very much.
Andrew just asked a question, Ellis.
Oh, sorry, I'm back.
That's okay. Just a question regarding availability and procurement based on the uptake, the increased uptake. Of,
yeah, good question. Yeah, the expectation is that we're looking at probably 20 or 30 times. You know, it's going to be a big demand increase as wastewater heat recovery gets used going forwards. We are very much ready to scale as a company, and we've been working towards this point for a number of years now. So as the only product that's stocked and sold as standard through the merchants, we're already building much larger number of stock through our merchant distributors, so they're holding much higher levels of stock than they ever have before. So that's ready and available for call off through branches. Recoup hold a large volume of stock ourselves in the UK, ready to supply via call off or through stocking into the distributors. And then also our manufacturer in Holland has stocks throughout the supply chain. So we very much are geared up for what we expect to be a big increase in demand from probably October, November onwards. However, that said, we are also working very closely through framework and supply agreements with developers, certainly the bigger developers, and we've been signing framework agreements to ensure supply through the merchants for those. So if you are a developer, if you're looking at wastewater heat recovery, give us a shout, because obviously the more visibility, forward visibility we've got, the more stock we can put into the market and be ready for it. So yes, hopefully that answers. If you're procurement, we have a completely different procurement presentation, which I'm more than happy to go through with you as well. Good. Everything, Craig?
That covers everything in the chat. Yep, thank you.
Good stuff. Well, thanks very much, everybody. I will respond very shortly, and we'll send the links for the CPD certificate and also the slides and the video online as well. Thanks very much.